Hello there everyone and welcome to this workshop on image generation with DALL-E. My name is Valentine and I'll be a facilitator. We'll first start this workshop or this course by learning the objectives of the session of the course. Then after that we'll get to talk about what image generation with DALL-E entails and why we would want to perform the related techniques. Then we'll go into a practice session where we will interact with DALL-E, which is a model, an image generation model, and we'll interact with it using the Python programming language. We'll provide some few challenges that will just ensure that by the end of the session, you are proficient in terms of creating applications using DALL-E, the model itself. And towards the very end, we'll just talk about the next steps. So let's get started. By the end of today, we expected to have achieved these learning objectives or learning outcomes. We should be able to understand the fundamentals of image generation with DALL-E. We should also be able to set up the DALL-E model in a Python framework. We should also be able to generate images using DALL-E capabilities. And lastly, evaluate the quality of those generated images. Starting off, what is image generation with DALL-E? So this is a process that involves the creation of images from textual descriptions using a deep learning model, more specifically the DALL-E model. And this model, which for ease of understanding, is just a computer program that has been trained on data, more specifically image data, would take in just some description that we would give in the form of text and give us an equivalent in terms of an image. DALL-E is one of the many OpenAI models that we can get to interact with. There are a few that you can use. There's GPT-4o, which allows you to be able to generate text from inputs, which could be either in text form or image form. And there's GPT 3.5 that takes in text and gives you text. And these, as mentioned, are models that are available from OpenAI at the time of publishing this course. DALL-E is one model that allows us to generate high quality images based on, again, text. And it generally would understand your prompts and undertake that process of image generation as a result of just trained that training process that it has already happened. So in terms of applications, we can use DALL-E, we as data professionals or even software engineers or data engineers, and we can use DALL-E to create platforms that allow us to help stakeholders such as artists or designers use the tool itself for inspiration or create unique artwork. Maybe they might have an idea of a specific image that they would want to create. So instead of undertaking the lengthy manual process of creating that image, they can simply describe what they want, and the model itself would give a description of, or would give an image that suits what has been given. But again, it may not be as perfect as you would want. There is so much that also happens when it comes to the text or the prompt that you give to a model. One would need to have that text or prompt much more descriptive so that a model is able to understand what you would envision for an image. Such other stakeholders that might also benefit from the applications that we build using DALL-E might be marketers who would want to generate images for campaigns that align closely with the product descriptions. There are also writers and content creators who would be interested in images that align with the textual content that they have. For interactivity purposes, in many cases, content creators would want to ensure that the readers are interested. So not only from just going through text, but also through images, through describing maybe scenes or describing objects or persons that are as described within the text. So as data professionals, we can use DALL-E with another tool like Python to create those platforms that allow us to perform all those steps. How it works, how DALL-E works, again, we would give it text input, which would generally be some textual description of the image we want to generate. And as a result, the model itself would process that input, and it would use what are called neural networks. And as a result, it would then generate an image that matches the description or the text that it was given. So, and you'll get to see the images that you get. Sometimes they could be realistic, sometimes they could be as described generally in the textual prompt. Sometimes you might want something that's realistic, then you can always tell it to have an image that's realistic, or you might want it to, you could tell it you'd want it to look cartoon-like, then it can also give you an image that looks cartoon-like, or like, comic kind of images. So it just depends with how you would want. In terms of limitations, there are a few limitations while we are using DALL-E. One is quality variability. Sometimes the images generated can vary. So you might get some image that may not necessarily look like what you had wanted. If you generate again using DALL-E, it might give you a different image, which slightly differs from what you had created earlier. So that's one thing to note. Interpretation challenges. Sometimes also when it comes to prompts, the prompts that you give, if they're too vague, if they're too broad, then you leave it up to the model to just decide how you want the image to look like. And that's not what you want. You want to ensure that the model just generates what you have given it. There's ethical considerations, as just with any AI generated content. So sometimes there's the idea of, do you generate content that probably might make some other people's roles obsolete. Like, for example, if you create a content or images that normally you would hire graphic designers to create those images for you, there's a question of, is that ethical? Well, it could be ethical. It's making work easier, but again, for them, they don't have, they lose jobs. And that's one of the issues. There are other issues in terms of ethical consideration. Sometimes you could end up generating an image of a person doing something, a real life, actually an actual person, and yet that person has never even done what you want to do. I mean, there are some images of popular actors doing funny things sometimes on some time back, and there were fake images, so they can lead to false information and people believing that those images are true. So the ethical considerations that one would need to take into account. But the providers of DALL-E, as well as other image models that generate images, have tried as much as they can to ensure that those models are not misused. All right, so at this particular point, I am going to ask you to visit the description. But before even visiting the description, it's also important to just talk about pricing for these models. And I'm going to share my screen right now. It's I've gone to the OpenAI website, which provides us with just pricing. There's a page that provides us with pricing for different models, and the one that we're going to be working with is DALL-E 3. It's the latest image generation model, and you get to see that per image you are charged this much. It's a bit pricey than what you would get if you were to use a tool, other tools. So this is something to consider. So you don't generate as many images as you'd want, because for each image that you generate, you're actually charged this much. And so you could always consider this, and before you even think about creating applications, to see whether it's a viable option, or is it feasible for the use case, or does it fit in within the budget that you would want to use, or does just would just hiring a graphical designer suffice? So that's something to consider. So at this particular point, visit the description link on the description section, and there's a link that will take you for the practice resource. If you click practice resource, it should take you to this page, and you can click on the sample practice resource, and then we can get started. So if you're an Afterwork member, you can try the practice notebook. So the practice has more challenges, sample just has 2. All right, so I'll just be using the practice one. So the first thing that you need to do, go to File, then save a copy in Drive. Should open a copy in a new tab, and then we can get started. I won't open mine in as a copy. I won't save mine as a copy. I'll just open it in playground mode, which will just enable a sandbox where I cannot be able to make changes to the original file. So once you've saved a copy, the next thing that we need to do is to connect our notebook to Google servers. And then we can get started. Should take just a few seconds, maybe 20 seconds. All right, so once it has connected, now as with any OpenAI model, we would need to import or install OpenAI, the OpenAI library, which you see here. So we use pip install OpenAI. So run that. You can just run anyway. Once it has installed, then we should be able to import the OpenAI class that we are going to use to set our API key. So run this as well, the next cell, by clicking there. By the way, if you feel like I'm too fast, feel free to pause the video or rewind it. Then you need an API key, because these services are not free. They use a lot of computational resources, and organizations have invested so much in them. So the OpenAI model is, again, as earlier mentioned, it's paid for. So you need to get an API key. This API key won't work afterwards. So just note that I'll have deleted it once. I actually delete it quickly after the workshop. So set your own API key by clicking, or so we create a variable, and we save it inside API key, and then we use the OpenAI class to create an object, a client object, and inside that we have this parameter API key. We set now to the variable or the value that we had set earlier. So here we're just setting our own API key, and then we should be good to go. So generating an image. So normally, as mentioned, we would need to create a prompt that we would give to the model itself, and that model would then create just images based on the textual description that we would provide. And there are many cases. The use cases, you can find use cases for this particular type of generation of images in advertising, in education, in content creation, etc. So let's first of all define our prompt, which we do here. This is a string, and we store it inside prompt variable. And then we create another variable called response that will take the results from the DALL-E model. So we use the generate function from the client object, and we are going to set as a parameter for the generate function the model parameters value to DALL-E 3. This is now the model that we will be working with, and we set our prompt to be this particular prompt here. And then once we have set that, we can run this code, and we will get our result from the model. We store it in response variable, but then the response that we get from the model contains a few more information, but it also contains a URL. And this is how we are able to reference that URL that will be generated, that we can use to get to our visualization, the image that has been generated. Then we save that URL inside the image URL variable. And then here we simply print out the URL, and then we can click on it. So yeah, let's run this. It should take maybe 5 to 10 seconds. And it's important to note that if you are to generate an image and you want to, yes, you have an application, you might want to store these images somewhere, because the link that you see here, it's usually valid for about 2 to 3 hours. I can't remember clearly, but after 2 to 3 hours, if you try to visit this link, your image won't be seen. So if I click on this link that has been displayed, it will take me to this page, and it will give me now the image of what I had asked. Like, what I had asked was an astronaut taking off from a desert to the moon with a jetpack. So you can see the moon is over here. The astronaut has a jetpack, and they're in a desert, and yeah, they're ready to go to the moon. So that's one particular, and you can use it in different cases, maybe for content creation, for maybe it could be maybe a library, a jetpack library in Python or whatever project that you might have. Or it could be, you could use it for this image for maybe in a story about an astronaut who, who decides to travel to the moon, and there's a whole lot of that. So that's one image. And yeah, voila, that's how you can generate an image. It's not that hard. And what we are going to do is that in the next section, in the challenge itself, you will find that you need to create a function to enclose the code over here, so that you can use it. You're able to repeat that code efficiently. So yeah, so that's generally how you just work with DALL-E to generate an image. But this is from a basic perspective, but if you want to further customize other aspects, so this is what we have. We had these two parameters, but what if we wanted to get maybe a different format? So let's pause the video, by the way, first, work on the challenge, and then once you're done, you can continue to quality. You can unpause the video, then we'll continue to quality. All right, so assuming we wanted to generate an image using an image that's of a higher quality, what we have here can be suitable for many cases. I mean, this it's good. It's actually some really good image. It's I think it's 1024 pixels by 1024. It should be 1024 by 1024 by default. But again, in terms of quality, it's just standard. But if we want a HD format, we can always use the quality parameter, then change this to HD, the quality parameters value, and then we can run the code again. So if I run this, so the prompt here is a photographer taking a photo of a penguin on the South Pole. So I can run this. It should now create for me a high quality image that I can use. Yeah, so let's do that. It should take a few seconds again. It's normally takes a few more seconds. So we have this link, we can visit the link. And again, once you've created an image like this, it's important to save it. You can always just right click, then save image as. Yeah. So this is our other image. Doesn't look that okay. Well, I'm not sure whether it makes sense. You can't wear like that in the North Pole. It's going to freeze, but maybe they decided, because that's what we asked. So we said a photographer taking the photo of a penguin on the South Pole, and that's what we got. And then we can use that image somewhere. We actually, to be telling you the truth, we usually use DALL-E to generate some of the workshop images that we have for the thumbnails. So it just gives us some extra twist. And when you look at the image, you'll be like, oh, okay, all right, does that make sense? All right, okay, maybe. So yeah, so that's something. Pause the video and then work on the challenge. All right, so moving on, we can also specify the the dimensions of our visualization. So initially, by standard, it's usually 1024 by 1024. You can see it's a square, but we can specify. There are 3 different sets of images that we can create. But again, you can create any of these, then crop them to what you would want. So for instance, if we wanted to specify or generate 1024 by 1024, we don't have to specify this. By default, it will be created like that, but we can do that. And then like here, we're going to generate a photographer taking a photo of a penguin on the South Pole. By the way, you'll see some inconsistency of this because this is our photographer, but if we ask again DALL-E to generate another model, we would have had to provide more details. Like we could have said that maybe this reporter should be from the Amazon forest taking a photo, and it would try as much as it can to understand how does a reporter who is from the Amazon forest look like. Maybe they might give them, like, clothes or coverings for that it would have learned maybe from a data set that contains indigenous people. So it would use that and get one of those people taking a photo. So yeah, let's just see what happens when we do this. So, but here you can note that we have set the size to 1024 by 1024, but we can set these other ones, and the quality is standard. By the way, HD is the most expensive one, so don't generate many don't generate many images. Think from the pricing, 10 HD DALL-E 1024 by 1024. Okay, it's 0.08. It's, I think, 8 cents. Here if it's slightly bigger, this is actually 12 cents. So US dollars, that is. All right, so we have generated our visualization, or not our visualization, our image. So this is a different reporter. So you can see them taking a photo. But when you look at the eyes, I'm not sure whether they look realistic enough, but I don't know. It looks okay. Yeah. I'm not sure whether people will focus so much on that. But this makes sense, slightly makes sense than this other one. This image may not be the best one because the reporter is not well dressed for the South Pole. It's cold there. Right, so that's just a bit of how we can define our quality, not the quality, the size of our image. Moving on, multiple images. In some cases, we might want to generate maybe multiple images. So instead of just having one image, you might want to generate multiple images at once. But now that's usually something that we can do in some other exceptional cases. It's not very much, but if you're going to be generating one image, you can also use some sort of for loop. So that way you generate the first image, you save it in a variable or in a list. That's the URL. So you can use a for loop to iterate through this as many images. But again, if you're not really concerned so much about quality, there's another model that we can use. It's the one that was before DALL-E 3. It's called DALL-E 2. By the way, pause the video and work on the challenge. So DALL-E 2 is a model that allows us to create multiple images. So we can use the n is equals to 2 parameter, n is equals n parameter, and we can set it to the number of images that we want. Like in our case here, we want 2 images. And we just use it the same way. Only thing that we do also different is just specifying the model name and the value of n. And then here, when we are returning response.data. We're not returning response, then the first item in this. It's a list data.url. So here we are retrieving the entire data. It should be a list. And then it could be a list or an object. I'm not sure. We'll have a look at it. And then we display that. So this response that we get here should have 2 URLs that we can be able to use to access our images. So that's what we're going to get here. So we have, when you look at here, we have, it's an object because of the square bracket, then a parenthesis over there. So we have the first URL, but if you scroll far to the right, we have again another object. We're actually getting two objects, and we can see it over here. So if we visit the first one, this is the first image. It uses DALL-E, but DALL-E isn't a clear of, it's not really as realistic as the previous one, but in some cases it might help with just simple images. So you can see here, but the reporter is not that detailed. Like there's there's not a lot of details with regards to the reporter. So let's click on our second link. Our second link looks like this, and the reporter is somewhere hidden over here. So we would have needed to do something about the prompt, like specifying that we want to see a reporter's face, how they should look like. But I think DALL-E 3 is much more intelligent than DALL-E 2. That's the model, and DALL-E 3 does a better job of just giving you what you want. The pricing also is slightly different. DALL-E 2 is slightly cheaper than the other ones. But again, what we're really concerned is the output. So yeah, so pause the video and then work on the challenge. And yeah, we'll talk about the next steps once you're done. Okay, so in terms of the next steps, again, I think the most important thing is to just see where you can be able to apply this particular tool. You can even have a notebook, just like the way you have, just create a new notebook, copy code that allows you to just generate a simple visualization using DALL-E, and you can reuse that notebook. You can always use that notebook whenever it comes to generation of images, especially for just content work or whatever case that you might have. But again, you need to also visit the documentation for OpenAI image generation. And because models usually change, you might find that after 2 months, there's DALL-E 4 or DALL-E 5 or DALL-E 4.0. So yeah, I think the recommendation would be work on projects, because they would help you to be able to acquire these skills and be able to put them into use. Yeah, so that would be recommendation, just work on projects. And there are other things that we haven't covered, like being able to edit images. You can be able to use that, but that's not supported in DALL-E 3. It's supported in DALL-E 2, but we didn't include it here because the images that you get are not as detailed as you would want. So DALL-E 3 does a good job of generating images, but they haven't provided support for editing. Maybe it could be that already it's there, the feature is there, but they haven't made it public for various reasons. All right, so that's it with regards to this particular learning experience. We hope that you were able to enjoy and learn something important. And if you did, be sure to give this video a thumbs up. And if you want to be informed when we post such future courses, which might be beneficial, it might equip you with 1 or 2 skills that might come in handy at one particular point in your career or in your work, be sure to subscribe, and all the best in your learning journey. Bye-bye.